Hello students, welcome to Narayana Online Digital Classes. So today's topic for PPT discussion is Newton's laws of motion. Okay, so let's see the first question. So here we have an arrangement here, a block of mass m, and you have a pulley and another two blocks are hanging like this. So it is given that m1 is 1 kg. Here this is 1 kg mass, okay? What is this? 1 kg mass. And what about mass of this? It is given as 2 kg, right? And what you have to find out in this particular case is for what value of m, that means for what value of this, m1 moves with constant velocity, okay? So for what value of this m, this m1 moves with constant velocity. That's what we need to find out. Here we have to neglect friction. That means all surfaces are smooth, okay? So suppose if it is released, it should move downwards with constant velocity. So that means its motion depends on its value, right? Mass of this block. Its motion depends on mass of this block. So what we have to do? We need to find out the value of m so that it will move with constant velocity. Clear? So for example, if you consider this diagram, okay, so this is 1 kg block. So I'll write this as 1 kg block. Let this be A, okay? Let this be A. So this block A will move with uniform velocity when net force on it is 0, right? That is the main condition. So to move this block with constant velocity, what is the main condition? Its velocity should be constant, means what? Net force on it should be 0. So what is the force acting in the downward direction? 1g, right? mg. What is m here? 1 kg. So therefore 1g is acting down. That means 10 newtons is acting downward direction. Suppose if the force acting in upward direction is also equal to 10 newtons, what will happen? Its velocity becomes constant. That is the main condition here. Hope you understood this point. That means we should maintain a tension in the string in such a way that it is always equal to 10 newtons. When it is 10 newtons, what will happen? Weight is acting downwards, whose value is equal to 10 newtons. Upwards force is also equal to say 10 newtons. Then what will happen? Net force on it becomes 0. When net force is 0, what will happen? Acceleration will be 0. If acceleration is 0, what would be velocity? It would be constant. So this is the condition under which we need to calculate mass of this. Hope you understood this point. So let's consider tension here is say T. And even in the string, it will be same tension. Why so? Because string is same. In the same string, tension is always same. That is a string constraint. You know that. So if it is T and T, then what would be the tension here? Obviously, it will be 2T. Am I correct? So if it is 2T, what would be the tension in it? It will also be 2T. Why? Because it is the second string, which is same string, right? In the same string, tension is always same. If it is TT, it would be TT. Then it will be 2T. Clear? So now let's find out acceleration for this block of mass capital M. So take block of mass capital M. What force is acting on it? 2T. Clear? So 2T. So it would accelerate in this direction. That acceleration, let's find out. So 2T is equal to mass times acceleration. This is the net force on this block. Am I correct? On this block, the only force is acting in the horizontal direction is 2T. So no other force, because this side mg and normal cancel out. As there is no motion in that direction, we are not interested about those forces. Anyway, net force along vertical direction on it would be 0. Now, 2T force is acting on it, so its force equation or equation of motion must be this. And we know that from this relation, T equal to 10 newtons. So I'll substitute T equal to 10 newtons here. Then I'll get m into EA. So from this, we'll get acceleration as 20 by m, right? So this is the acceleration for this block, okay? So for this block, acceleration should be how much? 20 by m meter per second square. So if this block has 20 by m meter per second square, as this is directly connected to this pulley would also be moving with same acceleration, correct? It will also be moving with same acceleration. So, and in this, acceleration is 0, but it will accelerate, correct? So what I meant to say is, with respect to this pulley, as it is lighter, it moves upwards, right? So with respect to pulley, this is 2 kg block, Therefore, I am assuming it moves downwards with some acceleration A. Now, I'll draw the free body diagram for block B. Okay, so let's see the block B. So, block B mass is given as 2 kg, right? So, in the downward direction, how much force will act? Its weight. So, how much is it? 20 newtons. In the upward direction, what is the force in it? Tension T. How much is T? 10 newtons. In which direction we assumed it is accelerating with respect to this pulley? It is moving right side, right? With some acceleration A. So it is moving in this direction with an acceleration EA. So what is that A? 20 by m. So if it is moving right side with 20 by m acceleration, it should also be, the pulley should also be moving downwards with 20 by m meter per second square, because they are directly connected with same string. So as this is moving downwards, as it is lighter, with respect to it, we can assume it is moving upwards with a constant velocity. So velocity should be constant. That means in this acceleration, we have to assume 0. But as it is moving down with an acceleration, with respect to it, it will also have same acceleration. So therefore, I'll give acceleration for this in the downward direction. Okay. So it will also experience pseudo force, yes or no? Because this is an accelerating frame. With respect to it, it will experience pseudo force. So the pseudo force on it is mass times acceleration. So mass is 2, acceleration is how much? Acceleration is how much? We have calculated. It is 20 by m. That's it. So now, if I write force equation for this, it would be 20 minus this 10, clear? This is 20 newtons, this is 10 newtons, minus, because it is moving downwards, the resultant force is downwards. So 20 minus 10 minus 40 by m. 40 by m should be equal to mass times acceleration. Its mass is 2 and its acceleration should be this. So if you simplify it, what you get, 20 minus 10 is 10. If you take this on right hand side, it becomes 40 by m plus 40 by m, because minus 40 by m becomes 40 by m. So plus 40 by m plus 40 by m, it becomes 80 by m. So 0, 0 cancel out and we get m equal to 8 kg. So this is the final answer for this question. Hope you understood. Hope you understood this. So here the main point you need to understand is, here this mass should move downwards with constant velocity, or it moves upwards with constant velocity. It should move with some constant velocity. So when it will move with constant velocity, when net force on it is 0. When net force will be 0, so downward force and upward force should be equal. What is the downward force? Its weight. How much is its weight? 10 newtons. Upward force is only tension. So if tension is 10 newtons in the same string, then always it will move with constant velocity. Under that condition, this mass should be 8 kg. Hope it is clear, right? So let's see the next question. Okay, so here you have an iron sphere in 3 different situations. Okay, so its weight is 10 newtons. The weight of iron sphere is 10 newtons, rests in V-shaped smooth trough. Okay, whose sides from an angle of, what I meant to say is these angles are given 60 degrees. So anyway, the data is very clear. What you need to find out is the reaction forces, basically normal forces. Normal reactions we need to find out, okay? So what we need to find out? Reaction forces. Reaction force means what? Normal force, that's all. So we need to find out normal force in all these 3 cases, clear? So let's see this case. So it will be like this. In this case, if I consider its weight, it will be acting vertically down. Clear? What is its weight? It is given as 10 newtons. Weight is how much? 10 newtons. Okay? Weight always acts vertically downward direction. And this is how much? 30 degrees. Actually, assume this is horizontal. Okay? Or otherwise, let's draw here. So weight is acting downwards. So mg. This is 10 newtons. Clear? This is 10 newtons. And we need to find out normal force at point A. So normal force at point A, on the sphere will be in which direction? So normal forces on the sphere. Here, on the surface it will act downwards. On the sphere it will act vertically up. So what I mean to say is, this is a horizontal surface. On a horizontal surface, if you have a ball like this, then here at this point, normal force passes through center of this one, and weight will be acting downward direction. So basically, you can directly say normal force at this point A should be equal to its weight. That means NA should be mg. So what is mg? 10 newtons. So that's all. NA should be 10 newtons. NA in first case. I am discussing case 1, this case. In that particular case, NA is how much? 10 newtons. So what would be NB? NB means this is the point of contact. From the point of contact, you have to draw a perpendicular like this. Okay. So NB could be in this direction, right? Now, if it is 60 degrees, what would be this angle? Right? See, this is vertically down, this is horizontal, and it is perpendicular to this surface. So obviously, this angle should also be 60 degrees. Why? Angle between any two lines is always equal to angle between their perpendiculars. You know that, right? So for these two lines, these two are perpendicular. So angle between these two should be equal to angle between these two lines. So if I resolve this into components, along this direction, you get NB cos 60. NB cos 60. Anyway, it is not moving in this direction. It is in equilibrium according to the given question. As it is in equilibrium, what you can say is NB cos 60 can be taken as 0 because there is no motion in this direction, but force is acting in this direction. So what you can write is NB cos 60 is 0. What does it mean? NB is 0. Okay, so that's it. So that means for case 1. So this is about case 1, right? In case 1, I got NA 10 newtons. Here RA is represented. Okay, so normal force can always be represented with either N or R. Okay, in some books it will be represented with R, in some books it will be represented with N. So we don't need to get confused. Okay, so NA is nothing but what? RA. So what is RA here? 10 newtons I have got. Clear? So that means this option is correct. But NB is how much? 0. Because there is no motion, it is in equilibrium at rest. It is tucked up between these two surfaces. It's not moving in that direction. You have a component which is in that direction. So NB cos 60 is 0. If NB cos 60 is 0, obviously NB will be 0, right? So therefore RB should be 0. So this is the correct option. Okay, so let's see the next case. So in this case, also we need to find out RA and RB. Okay, so this is RB. So RA and RB values means normal forces at these points. So for example, if I consider this diagram here itself, I can write, let us assume this is the center. Normal reaction should always pass through center of this spherical body. Am I correct? For spheres, cylinders, for circles, if you draw a normal, it should pass through center. So same thing happens even in this case. So I have to draw a normal like this. So it will be in this direction. So I'll write RA now, okay? And here, if I draw perpendicular from here, it should pass through this, okay? So this is RB, clear? So if I consider the center, from this point, you have one RA, another one RB acting in these directions. So in this direction, what will be acting? Its weight must be acting. What is the weight here? What is the weight given here? 10 newtons. So this is the 10 newtons force. Weight is acting downward direction. Okay. So I'll take a fresh diagram here. So you have sphere which is tucked up between these two. So its weight will be acting downward direction, mg, like this. So one normal force will act like this. Another normal force must be acting like this. Clear? So what is this point? B. What about this point? A. So this should be RB and it should be RA, correct? So now let us produce this line. So this is the vertical and here it is given 60 degrees, correct? It's actually symmetric figure. So therefore it should be 30. It is a normal 90. So how much is this? 60. Same story here also, correct? So therefore this is also 30, this is 90. So obviously it will be 60. If this is 60, 60, you can say this is vertically opposite angle, 60, 60. So now we can resolve this into components. Along this direction, you have RB cos 60. Similarly, RA cos 60 also acts in this direction, correct? RA cos 60 will act like this. Along horizontal direction, if you take, in this direction, what will act? RB sin 60. Here RA sin 60 will act. Clear? So if you can understand that RA and RB are same. RA and RB are same. Correct or not? Along horizontal direction, the equation we'll get is RA sin 60 is equal to RB cos 60. Sin 60 cancel out, RA equal to RB. So here if you see the vertical equilibrium, for the vertical equilibrium it should be RB cos 60 plus RA cos 60. How much? 2 RA cos 60 I can write. Why? Because RA and RB are same, right? So therefore it should be equal to mg. So it should be equal to mg. So cos 60 and 2 cancel out. Cos 60 is 1 by 2. So therefore you get RA equal to mg. Mg is given as mg is nothing but weight. It is given as 10 newtons if you read the question. So RA is 10 newtons and RA and RB are same in this particular case. Clear? We have proved RA equal to RB. So if RA equal to RB, then RB is also equal to 10 newtons. So that's all. So hope this is clear. So here RA is acting like this, RB is acting like this. So directly you can write RA cos 60, RB cos 60 equal to mg. By symmetry says that these two must be equal. So 2 times RA cos 60 is RA equal to mg. That is also equal to RB. That's it. So that means let's say for case 2. So RA is 10 newtons, RB is 10 newtons. So this is also correct. That is also a correct answer. And see the last one. So RA is 10 newtons, RB is 10 newtons in all 3 cases. Not correct. Fourth option is obviously not correct because in first option these two are different. Second option, of course, they are same. So now in the last case, what you have to find out is RA, RB again. Okay. So let's see here. Okay. So if you consider this point, from here weight acts. Weight is how much? 10 newtons. And from this point, RA will act. And from here RB will act. Okay. Now you need to resolve this into components. Okay. So RB is perpendicular to this one. RB is because it is vertical, so RB will act perpendicular to this surface, and weight is acting like this. You produce it like this. Okay. So you can say so this angle is 60 degrees. Okay. So I'll take a fresh diagram. So this is it, and its weight will be acting down, and it is 60 degrees, and this is the point. This point is represented as B. So RB will be passing through this one. So this is RB. And similarly, from this point, RA will be acting like this. RA will be acting like this. So if it is 60, and these two are at right angles to each other, these two are at right angles to each other. If this is 60 degrees, obviously, this should also be 60 degrees. Why? Why? Angle between two lines is always equal to angle between their perpendiculars. So therefore, I can resolve this RA into components at along this direction. Okay, along this direction, RA cos 60, RA cos 60, and vertically downward direction, weight is acting. So I can write RA cos 60, RA cos 60 equal to weight, which is mg, right? What is mg value? 10 newtons. Cos 60 is how much? Okay. Similarly, you can find out RB. Okay. So what would be RB in this particular case? RB is this one. Okay. RB is perpendicular to this one. RA is acting like this, normal to this one. So angle, this is 60 degrees. So if you simplify this, what you will get is what you will get is RA equal to 20 root 3 and RB would be 10 by root 3 newtons. Okay, so that means first three options are correct and last option is not suitable. Okay, so that's all about this question. So let's move to the next one. So we have a block of mass m, and here there is a light string, and there is of course friction is acting. So what is the time in which the bead loses contact with the string after the system is released from rest? Now the system is released from the rest. So the system is released from rest. So there is a bead here. What will happen to that bead? It moves downwards. Am I correct? It will move downward direction. Am I correct? So when it is moving in the downward direction, when the system is released, what will happen? It will move downward direction. And bead also moves downward direction. As it is moving in the downward direction, obviously this bead will be, this string will be moving upward direction. Able to understand? When it is moving downward direction, bead will move downwards. Bead will move downwards. String will move upwards. Hope you understood this point. This block is moving in the downward direction. As the block is moving in the downward direction, what will happen to this bead? Bead will also move downward direction. It has same mass, so it will move downward direction. But string will be moving through the bead in upward direction. So here, what forces will act in this direction? If you consider bead, so its weight will be acting in the downward direction, and it is given that there is a friction which is acting in opposite direction. Friction always acts in opposite direction to that of the motion of the body. As it is moving down, okay, friction is acting in upward direction like this. So this is the frictional force. So what would be the net force here? So the net force on the bead is nothing but mg minus mg by 4. So what is the acceleration? G minus g by 4, correct? G minus g by 4. So how much is this? 3g by 4, clear? This is the acceleration with which bead is moving in the downward direction. But the thing is, string is moving up, bead is moving down, and it has to lose contact. The bead has to lose contact. That means it should fall from here. Am I correct? At the end, on reaching this end, means on traveling L distance, it has to leave this string. Able to understand? So how much time it will take for it to leave the string? Able to understand this point? So for that, how much time it will take? So string is moving, bead is moving. So therefore, what I'll do is I will take relative velocity between these two. Okay. So what is the relative velocity of bead? Relative velocity of bead with respect to string. Relative velocity of bead with respect to string is nothing but string is moving up with an acceleration because it's falling downwards. So therefore, it is moving upwards with an acceleration g. So acceleration of bead with respect to string, if I calculate, that would be actually acceleration of bead is 3g by 4 minus acceleration of string is g. Opposite direction, I'll take negative sign. So I can write this as 7g by 4, okay? Hope you understood. I'm taking in this particular case downward direction positive, upward direction negative. I can take like this, okay? So any direction you can assume it to be positive. So bead is moving in the downward direction, string is moving in the upward direction with an acceleration z. So therefore, this is the relative acceleration. Able to understand? The relative acceleration is 7g by 4. So what we have to find out now is after what time it leaves the string. That is it. So for that, what you have to do is use this formula s equal to ut plus half at square. But in this case, u is 0. Why u 0? When released, bead starts from rest. So what is the distance it will travel when it falls down? L. L equal to half into, here you have to take relative acceleration which is equal to 7g by 4 into t square, okay? So we need to find out t. So t square equal to 8 times L by 7g. So make t as subject, it would be under root of 8L by 7g. So this is the answer for this question. Hope you understood. So mg is acting down, friction is acting upwards like this, and it is accelerating downward direction. So its acceleration we can calculate using a force equation. So what are the forces that are acting on this bead? Mg is acting down, mg by 4 is acting up. So net force becomes how much? 3 mg by 4. If net force is 3 mg by 4, what is the net acceleration? 3g by 4. Okay, so I got acceleration of the bead. So string is moving up with an acceleration g, correct? So bead is moving down with an acceleration 3g by 4. So relative velocity with respect to string would be how much? 3g by 4 minus of minus g, because they are moving in opposite directions. Obviously relative acceleration becomes what? 3g by 4 plus g. So 3g by 4 plus g would be how much? 7g by 4. This is the relative acceleration. When you have relative acceleration, that means we are stopping one of these two bodies, string and bead. When both are moving, then we have to calculate, isn't it? For that, the convenient method is we'll stop any one of them. With respect to that, we'll calculate the relative acceleration. So anyway, relative acceleration is 7g by 4. So s equal to half into a relative into t square. So from this, you can calculate t value, okay? So t becomes root of 8l by how much? 7g. In this particular problem, this value you need to find out. So in place of n, you have this 8. So therefore, the final answer for this question is n equal to 8. Hope you understood this, right? Here, anyway, friction is not completed, but still you can understand that friction is nothing but some resistive force. So that's why I took it in opposite direction. Some resistance force for its motion is acting in upward direction, mg is acting in downward direction, so net force becomes how much? 3 mg by 4. Net acceleration becomes 3g by 4. So relative acceleration becomes, with respect to string, if you stop string, then what would be the acceleration of the bead? It will be 7g by 4. So now string is at rest, bead is falling down with an acceleration of this. How much time it takes to fall L length to lose contact is calculated. Hope you understood this question, right? Let's see the next one. Okay. So here we have a system, pulley block system. So here already mentioned tension is T2, here tension is T1, this is M1, M2. So let's see M1 is how much? It is 5 kg. So this is a 5 kg mass. And M2 is given, how much is this? This is a 2 kg mass, okay? So we have two blocks, right? Which passes over the pulleys as shown in the figure. The threads are massless, that means they're all ideal cases. And what actually you need to find out is magnitude of value of acceleration of M1 with respect to ground. So that means acceleration of M1 we need to find out in the first case, and second case acceleration of M2 we need to find out, and we should also find out tensions in the strings. That means basically we have to find out acceleration of 1, acceleration of 2, T1, T2. We have 4 questions here. Okay, hope you understood. So when this system is released, what we expect? This is heavier one than this. Therefore, generally, we can expect that it is moving downwards, okay? So let its acceleration is A1, right? And when it is moving downwards, obviously, it goes upwards with an acceleration, say, A2. Clear? So now, we need to find out constraint relation between them. That means A1, A2 relation we need to find out. After that, we need to find out, force equations for these two blocks. Okay, so here how many unknowns are there? How many unknowns are there? We have T1, T2, A1, A2. So using constraint, we can find out the relation between these two. Let's do that first. Okay, so I'll use virtual work method. So in that method, here T1 is acting upwards. Therefore, this is also T1, obviously, because this is all same string till here. So this is T1, right? What is this? T1. Because you have a single string here. In a given string, tension is always constant if it is ideal or massless. Again, you have a different string here. In this, tension would be different. If it is T1, T1, obviously it should be 2T1, correct? If it is 2T1, it will also be 2T1 because it is same string. So what is T2 then? T2 is 2T1. We have eliminated one unknown, right? One variable, I mean to say. So now, we have to find out, able to understand, T2 equal to 2T1. T2 equal to TT1. So T2 is 2T1, that is one equation for us. Now, so if you consider free body diagram of this, what forces are acting on it? So on 5 kg mass, this is 2T1 and it is T1. So I'll write here, this is how much totally? 3T1. 3T1 is acting up and 5G is acting down. 5G is acting down and acceleration 1 is acting down. Okay, so right. Now consider the second mass. If I consider the second mass, its mass is basically 2 kgs. So 2G is acting down. Okay, and only tension. Okay, so this is T1, this is T1. What is the tension here? Obviously 2T1. So 2T1 tension is acting here, right? So what is the direction of acceleration? It is moving down, so it is going up with an acceleration A2. So this data is enough for us to solve this questions. Okay, let's see here. So tension is upwards, acceleration is downwards. So work done by tension in this particular case is 3T1 into A1, which is negative work. And here body is moving up, tension is also acting up. So work done by tension in this case is positive. So I'll write 2T1 into A2. Okay, it should be 0. Why? Net work done by tension in pulley block system is always equal to 0. Hope you understood. Or otherwise, in any of this kind of systems, net tension is always 0. As net tension is 0, net force is 0. If net force is 0, net work done will be 0. So this is the net work done. So it is 0. So T1 cancelled. I have minus 3A1 plus 2A2 is 0. This is the constraint. That means 2A2 equal to 3A1. This is the relation between A2 and A1. Clear? Okay, so this is my equation 1, right? So this is the equation 1. Next, let's write force equations for this too. So what is force equation for it? 5G is acting down. I'll take it as 50. Minus 3T1 is equal to, so what is its mass? 5 kg equal to 5 times A1. That's it. 50 minus 3T1 equal to 5 times acceleration. This is equation 2. For this, let's write equation of motion. So what would be equation of motion for it? It's going up. So net force is upward. So 2T1 minus 20. Okay, 2T1 minus 20 equal to 2 times A2. Clear? 2 times A2. Okay. So we have here 3T1, we are 3T1, okay. So what I'll do is I'll multiply it by 3. If I multiply it by 3, what I'll get is 61, okay. 61 minus 20 into 3, 60 equal to 6 times A2. 6 times A2. Okay. 6 times A2. Clear? Let's multiply this by 2. Equation 2 I am multiplying by 2. Then I will get here 100 minus 61 equal to, you're multiplying it by 2. So it will be 10 times A1, correct? So in place of this, what I'll do is I'll substitute A1 so that we'll get A1 value, okay? So when I multiply this by 3, what I am getting? 61, right? Minus 60. Because I am multiplying it by how much? 3. So minus 60 is equal to 2 times A2. 2 times A2 can be taken as 3A1, right? 2 times A2 can be taken as 3A1. So 3A1 into 3. How much? 9A1 I can write directly. So instead of writing like this, I can directly, convert this 2A2 into 3A1 and multiplying it by 3, I will get 9A1. Hope you understood. So what I'll do is, I'll resolve this to The point is, I'll add this 2. On adding, minus 6 cancel out. So 100 minus 60 is 40. So 40 equal to 90 times 19 times A1. So what is the acceleration here? We get it as 40 by 19 meter per second square. So I have calculated A1. If I have A1, I can find out A2. So what is A2? A2 is 3 by 2 A1, right? So 3 by 2 A1 means how much? 3 by 2 into A1. A1 is how much? 40 by 19. Okay, so this is 2 20s. So 3 20s are 60. 60 by 19 meter per second square. So I have calculated A1 and A2. Clear? See here, 60 by 19 is what? A2. Okay, 40 by 19, A1, right? So this is A1, right? This is A2. I have calculated these two values. Hope you understood, right? So this is acceleration of M1. M1 acceleration is this. And this is acceleration of M2, which is equal to this. Is that clear? So we got A1, A2 values. Then we need to find out tensions, right? How to calculate tension? You can substitute A1 and A2 values in any one of these two equations. Which are our main equations? You can use this one or you can use this one, okay? So, so let us find out tension, okay? So let's find out tension. So this is your 2T1. 2T1 is equal to 20 plus 2 times A2. Clear? So that is equal to 20 plus 2 times, what is A2? What is A2? A2 is this, okay? So 2 times 60 by 19, okay? Right? You can simplify this further. So T1 can be written as 10 plus 60 by 19. Clear? Because 2 is common in all these three terms. So this 2, this goes 10 times. Here 2 cancel out. And finally what you have is T1 equal to 10 plus 60 by 19. So 19 plus 10, 19 into 10, 190 plus 60, 250. So finally you are getting 250 by 19 newtons. Hope you understood. So I have calculated T1 as 250 by 19. So let's see here. This is the T1 value. Hope you understood. This is your T1. So what is the relation between T1 and T2? Already we have discussed in the beginning itself. 2T1 is T2. So if 2T1 is T2, how much it would be? Double of it, correct? So that means this is the T2 value, correct? So this is correct. Okay, so that means for D, P is the correct answer. For C, Q is the correct answer. For B, this is the correct answer. For A, this is the correct answer. That's how you can analyze this question. Able to understand? Okay. Let's see the next question. Okay. See here, we have 3 blocks, 3 kg, 2 kg, 1 kg, and this is 30 degrees. All surfaces are smooth, and from this side 60 newtons, and from this side 18 newtons force is acting. So what we have to find out, let's see. Here, acceleration of 2 kg block is how much? That means its acceleration is how much? Net force on 3 kg is how much? And normal reaction between these two is how much? Normal reaction between these two is how much? So these are the questions we need to calculate, okay? Hope it is clear, data. So it's an inclined plane, inclination is 30 degrees, forces, masses, everything is represented, all surfaces are smooth. So therefore, directly we can find out acceleration using the formula. Acceleration is net force by total mass. This formula we can always use, net force by total mass. So what is the net force here? If you consider this one, 60 newtons is acting up, 18 newtons is acting down. So in the downward direction, can I say it is 48 newtons? Of course. Upwards is 60, downwards is 18. So what is the net force acting? It is 42 newtons in upward direction. And you can assume, as they are all in contact, you can assume 6 kg is on the inclined plane. So you can assume like this. You have a block which is 6 kg. Total 3 plus 2 plus 1, total mass 6 kg. So in this direction, what force is acting? 60 newtons, right? In this direction, how much is acting? 18 newtons. And it is on an inclined plane, right? It's on an inclined plane. What is the inclination of this? 30 degrees. Obviously, in the downward direction, mg sine theta will act, you know that. So what is mg sine theta value? 6g sine 30. Okay, so 6g sine 30 is acting down, 60 is acting up, 18 newtons is acting in the downward direction. What is this? 18 newtons. 18 newtons is acting in the downward direction. So, so 6g sine 30 is nothing but 6 5 is 30. Okay, this is 1 by 2, so into 10, 5, 6 5 is 30. So in this direction 30, in this direction 18. So downward direction is 48, upward direction is 60. So net force 60 minus 30 minus 18 equal to mass times acceleration. That way I can write. Able to understand? This is all net force, mass times acceleration. What is the mass here? Total mass, 6 kgs. 3 plus 2 plus 1. So what is the acceleration? Let us assume A. So what forces are acting on it down the plane? If at all it moves only on the plane, right? Okay, on the inclined plane. So no motion along vertical direction. So forces acting along this direction, we are not interested at all. So let us ignore about them. So from this, what you get is acceleration equal to 12 by 6, which is equal to 2 meter per second square. Okay, so this is the acceleration, which is 2. So that means for block A, this answer is correct. 2 meter per second square is correct. So acceleration for the entire system I have calculated, okay? So this is equal to 2 meter per second square. All are moving together. So this would be common acceleration. I can say common acceleration. So that means it is the acceleration of 3 kg, 2 kg, 1 kg. So for all the blocks, acceleration is common. So therefore, acceleration for 2 kg only is the question here. So it also moves with same acceleration, which is 2 meter per second square. Okay, net force on 3 kg block is how much? What is the net force on 3 kg block? Net force is always mass times acceleration. Second law says that only now. What is second law? Newton's second law. Newton's second law says net force acting on a body is always equal to mass times acceleration. So its acceleration just now we have calculated. What is the acceleration in this direction? 2 meter per second square. It is, 60 is greater force than this 2. 60 is greater force than these two forces. mg sine 30 is 30 only. This is 18. So therefore, it is accelerating upward direction. And up the plane, acceleration is taking place. And 3 kg acceleration is also same too. So therefore, F net on 3 kg is its mass times acceleration. So which is equal to 6 newtons. Hope you understood. Net force is always mass times acceleration. Okay. What is the mass of 3 kg? Mass of this block? 3 kg. What is its acceleration? 2. So totally 6 newtons. So that means you can say net force on 3 kg block is nothing but 6 newtons. 6 newtons. I'll write units. Anyway, units I will write here. 6 newtons. So now what else we need to find out? Normal reaction between 2 kg and 1 kg. So between these two, what is the normal force? That's what we need to find out. For that, here what actually happens is 1 kg block pushes it in this direction, 2 kg push it in this direction. So now I'll take a free body diagram of 1 kg block. So let us take free body diagram of 1 kg block. So what forces are acting on it? So 18 newtons is acting in this direction, clear? And 2 kg block, exert force on it in this direction, let us say N. This is what we need to find out. Let's say N or N1, okay? So this is the pushing force between these two. Okay, any other force acts on it? Its weight component will act down the plane, correct? So if you draw like this, its weight will be acting downwards. 1g is acting downwards. If it is 30 degrees, it would be 30. And along this direction, 1g cos 30 will act. 1g cos of 30 degrees will act. So this is the actual normal force. So along this direction, 1g sin 30 will act. 1g 1g sine 30 will be acting. Okay. So these are the forces acting on it. Okay. If you see this direction, 18 is down, n1 is up, and 1g sine 30 is how much? Sine 30 is 1 by 2. So it will be g by 2. So its value is 5. So 5 is acting down. Okay. 18 is acting down. Okay. And it is accelerating actually upwards. Okay, now? So therefore you can write, as it is accelerating upwards with 2 meter per second square, you can write n1 minus 18 minus 1g sine 30. Why 1g? Its mass is 1 kg. 1g sine 30 is how much? 5 equal to mass times acceleration. That's it. So what is its mass? 1 kg. What is the acceleration? 2. So what would be n1? n1 equal to 2 plus 5 plus 18. So total is how much? 25 newtons. Hope you understood this. So this is 25. So that means for this, the answer is this, and it is newtons. In newtons, because it's a force. The pushing force between 2 kg and 1 kg I have calculated. Hope you are able to understand here. So first question is net force acting on it equal to total mass into acceleration, or acceleration equal to net force by total mass. So net force is calculated as 12 newtons, total mass is 6, so that a common acceleration I got 2 meter per second square. All the blocks are moving in this direction with 2 meter per second square. That means 3 kg, 2 kg, 1 kg, all these 3 blocks, acceleration is same, which is 2 meter per second square in upward direction. Okay. So to find out normal force between these two, this is, suppose say this is action, it would be reaction. These two are always equal. So any body we can take, I selected 1 kg block. So the forces acting on it are 18 down, and normal force due to 2 kg acts in this direction, and weight component down the plane 1g sine 30 or mg sine theta will be acting down the plane. So net force equal to mass times acceleration. Mass is 1, acceleration is 2. So if I make n1 as subject, we'll get it as 25 newtons. So that is about this third option. Okay, let's see the last one. What is the normal reaction between 3 kg and 2 kg? That's what we need to calculate. Okay, normal reaction between 3 kg and 2 kg. So actually these blocks are moving upward direction. So it will be pushing it in this direction. So that will be pushing, 2 kg will be pushing it in this direction. So there is a force which is say N2 between them. Now take a free body diagram of this 3 kg block. So suppose if I take this as my 3 kg block, what forces are acting on it? So down the plane, along the incline, 60 newtons is acting, correct? And 2 kg exerts force on it like this. So that means I'll take this as my N2. And it is accelerating upwards with 2 meter per second square, clear? And angle of inclination is 30 degrees. And any other force is acting on it? Weight component down the plane acts. So weight component down the plane is how much? It is mg sine 30. M is how much? 3. So 3 into g sine 30 is 5. So 3 5s are 15. So 15 newtons is acting down, 60 is acting up, N2 is acting down, acceleration is up. So for this situation, you need to make force equation. So I'll write the force equation for that situation. So 15 is down. What is 15 actually? Mg sine 30. What is M? 3. 3 into g is 30. 30 into sine 30 is how much? 15. So 15 newtons is acting down, N2 is acting down, and 60 is acting up, acceleration is up. That means 60 is greater force. So therefore 60 minus 15, okay, minus N2, opposing its motion. So that is equal to 3 times acceleration. So 3 times 2. Acceleration is 2. So 60 minus 15, how much? 45. 45 minus N2 equal to 6. So I need to find out N2. So what is N2? 45 minus 6. So it will be 39 newtons. So this is normal force between 3 and 2 kgs. So between 3 and 2 kg is 39, between 1 and 2 kg is 25, total system acceleration is 2 meter per second square. Able to understand? Okay, so hope this is clear, right? Is that clear? Right, let's move to the next question. Okay, so here you have a situation where all the surfaces are frictionless and you have a wedge here, and in column 1 acceleration of block with respect to ground, acceleration of block relative to wedge, and normal force by block on wedge, net force on the wedge. Its directions you basically need to show. That's it. According to the question, what we can understand is these are the directions for these cases. Okay. So what actually you need to find out in this particular case? Acceleration of the block relative to ground, acceleration of block relative to wedge means directions. Basically directions. We don't need to calculate any magnitude. Only directions we need to show. That's it. So hope you understood the question. In this column 2, you have directions. In column 1, the quantities that we have to calculate. Okay, so assume that the system is released. Okay, all these are free to move. That means it is on a smooth surface and all are free to move. Assume it has some mass m. Okay, so mass is nothing is mentioned anyway, not required. So let's see the first question. Acceleration of the block relative to ground. Acceleration of block relative to ground. Okay. What is the acceleration of the block relative to the ground? Okay. So what actually happens is you have a wedge here and this is a block. So block exerts some normal force on it like this. What is this? Normal force. And if it is theta, it will be theta, right? So you can write this is n cos theta and this will be n sin theta, n sin theta. That means this block is exerting this much force in horizontal direction, because of which it will have some acceleration along horizontal direction. So let it be acceleration of the wedge. So what is acceleration of wedge? Along this direction. So this is the normal force. This is the force exerted by this on this wedge. So this normal force has two components, n cos theta down, n sin theta horizontal. So because of downward force, it cannot move downwards because it is on a horizontal surface, but it can move right side. Okay, so let us assume acceleration of the wedge is in this direction. Okay, so therefore it is an accelerating frame and this block is on it. So therefore it can experiences pseudo force in this direction. As it is on a smooth surface, mg sin theta pulls it down. So therefore it will have some acceleration in this direction. That means simultaneously it has two accelerations. The resultant will be along this direction. If you consider parallelogram law, this would be the direction along which it can accelerate. Okay, hope you understood this. So that means than this it is more steeper. So I can say say this is the direction for acceleration with respect to ground. Why? This is the acceleration of the wedge. This is the direction along which pseudo force acts. Correct? Therefore, it has a component along this direction. Right? It is sliding down. So along this direction also it has acceleration. Resultant can be this way. Okay? So resultant force can be this way. So you can assume it to be correct. Next, acceleration of the block relative to wedge. Acceleration of the block relative to wedge. So acceleration of the block relative to wedge is nothing but this one. Okay. This is the incline and you have the block. It is sliding down like this. With respect to relative to wedge means what? Observer is wedge. You have assume that this is the observer. Okay. So with respect to this observer, it appears to be sliding down like this with some acceleration A. So therefore, this is the direction, right? If it is theta, obviously, if I draw horizontal, it will also be theta, alternate angles. Am I correct? That means this can be correct answer. Able to understand? With respect to the wedge, say wedge is observer, say this is the observer. What he observes, it is sliding on it like this. So that means this is the acceleration. This is the acceleration with respect to the wedge. This angle is a theta. So this angle will also be theta. If this is horizontal, this is also horizontal. So this will be alternate angle. So therefore, this is correct for this B. Okay. Next, normal force by block on the wedge. Normal force by block on the wedge. Okay, I have already shown it. This is the normal force by the block on wedge is this. Okay, so with respect to vertical, it makes an angle theta, because if it is theta, it should be theta. Why it should be theta? Angle between two lines should always be equal to angle between their perpendiculars. So this is perpendicular to incline, this is vertical, it is horizontal. So this angle and this angle must be equal. So n cos theta, n sin theta, and this is n. So normal force is like this, and vertical is this angle is theta. So obviously, this is the correct answer. Okay, with respect to vertical, it should make theta, that's it. See, this is the surface, this is the normal, okay, this is the normal, and this angle should be theta. Why? This is theta. This is perpendicular to this one, and these two are perpendiculars. So obviously, angle should be same. So therefore, for this is the correct answer. And the last one, net force on the wedge is how much? So net force is this only, okay, there is no other force. Okay, why? N cos theta is balanced by normal force due to ground. Okay, so therefore this is the net force. Net force is n sin theta, and it is acting in this direction. This is the net force. Okay, so therefore net force will be in this direction. So this is correct, horizontal. In the net force direction only body accelerates. Basically, we know that always any body accelerates in the direction of net force. So net force acting on it is in this direction. So that's the correct answer. Okay, hope it is clear. So let's go to the next one. Is that clear? Okay. Okay, you have an inclined plane. Angle of inclination is alpha, and it is also shown moving in this direction with an acceleration A, and there is a string here. So what actually we need to find out is the acceleration if the body pushes the plane with a force of, okay, this block is pushing the plane. You know, this is the inclined plane, and you have a block here, and this block is pushing it with a force, actually normal force only now. Block exerts normal force only on the incline. So this normal force is given as 3/4 mg. 3/4 mg. So read this question. A body of mass 1.8 kg. You have a body here whose mass is 1.8 kg. Clear? And angle of inclination is given as 37 degrees. Clear? So, and it is attached to this wedge, okay, which is by means of a string, and string is parallel to the incline, okay, and you can neglect friction. So here what you have to find out is acceleration if the body pushes the plane with a force of 3/4 mg is. Able to understand? So what is the acceleration if the body pushes this with this force? That means basically normal force is given. What you are asked to find out? You are asked to find out acceleration. So that's it. Clear? So that means basically we need to find out, equations. First of all, we have to make force equations from its free body diagram. So let's see. N is on this, N will act like this. Okay? And on the block, N will be acting like this. And its weight will be acting vertically downward direction. This is actually 37 degrees. If it is 37, obviously it will be 37. Along this direction, what will be acting? Mg cos 37 will act. Mg cos 37 will act. Clear? And along this direction, what acts? Mg sin 37 acts. Mg sin 37 will be acting. Actually, it is on an accelerating frame. It's given that it is accelerating like this with acceleration A. So therefore, it actually experiences a pseudo force. In which direction it experiences pseudo force? In opposite direction to that of it. So that means I will take acceleration along this direction. Means pseudo force along this direction. Okay now? So what is this? Pseudo force. Fp is a pseudo force, say. So if it is 37, it will also be 37. Clear? this is 37, right? These two are alternate angles, obviously 37. I'll resolve this into components. So along this direction, MA cos 37, and in this direction we get MA sin 37 will act. Okay, so if you see in this direction, the equation that we get is N plus mg sin 37 should be equal to mg cos 37, right? Mg cos 37. I have one equation here, n equal to n plus mg sin 37 equal to mg cos 37. The other equation we get from this, another force acting on it is tension, right? There is a tension here in the string, so I should write tension. Okay, so for its equilibrium, tension should be equal to sum of these two forces. These are mg cos 37 so plus MA cos 37, that's all. This plus this, that's all. Equal to what? Tension acting in this direction. For its equilibrium along this should be equal to sum of these two forces. I have written mg sin 37 here, MA cos 37 here. This is the tension equation. Along the inclined plane, this is the force equation. Perpendicular to the inclined plane, this is the force equation for this question. Hope you understood. And n value we have. N is given, indirectly n is given like this. What is this actually? Basically it is the force exerted by this block on the incline. That value is given how much? 3 by 4 mg. So I will substitute this value. It is 3 by 4 mg plus mg sin 37. Sin 37 is 3 by 5. So I can write it as 3 by 5 mg equal to mg cos 37. Cos 37 is 4 by 5 mg. That's all. Okay. So I have substituted the values. Okay. So this is MA sin 37. Okay. So let's make A a subject in this equation. See here, this is A, this is MA sin 37. So this is MA sin 37. So it should be EA. Sin 37 is 3 by 5. N 3 by 4 mg given. What about this? Cos 37 is 4 by 5 into this mg. So here the only unknown is A. That I need to make as subject. That's it. So therefore 3 by 5 MA equal to 4 by 5 minus 3 by 4 mg. That's all. Okay, cancel basically. So how much it will be? You have LCM 20, so 16 minus 12, right? Okay, now? So 5 4s, 4 4 16, 4 5s, 4 5s, 5 3s, this is 15. So into G, that's all. So this is how much? 16 minus 15 is 1 by 20 into 10. So it will be, G and this can be cancelled. So I get 1 by 2 on this side, and this side I have 3 by 5 EA. So if I make A as subject, I am getting 5 by 2 into 3. So meters per second square. So this is how I can find out the acceleration of this particular wedge. Okay. So acceleration is 5 by 6 meter per second square. So answer is this. Okay. So this is the correct answer. Fourth option is correct. Hope you understood. Able to understand? So see once again, this is the block. On the block, what forces are acting? Basically, we have to represent those forces. So the forces I have represented here. N is acting on it, exerted by this, N is exerted by this inclined plane on it. And pseudo force acts in opposite direction to that of this inclined plane. Because inclined plane is moving in this direction, obviously pseudo force on it should be MA. T will be acting in that direction. MG will be acting vertically downward direction. Okay, normal is acting normal to the inclined plane. So what I have to do is I have to resolve all these forces along the incline and perpendicular to the incline. That's it. Along the incline, what forces are acting? T is acting up, and these two components acting down. Perpendicular to the inclined plane, what forces are acting? N, MA sine 37. What is this? MA sine 37, which is its component, pseudo force component. Along this direction, weight component mg cos 37 is acting. So therefore, n plus ma sin 37 have equated it to mg cos 37. I got this equation in which n is given, so I have substituted it and made a as subject. I got the correct answer. Hope you understood, right? So let's see the next question. Okay, so this is. So what you have to find out in this particular case is tension in the thread in the above question. Means in this particular question you need to find out what is the tension. Arrangement is same. So what is alpha value? Given alpha is same 37 degrees. So I'll write it as 37 degrees. What is this mass? 1.8 kg. What we have to calculate? Tension. For that what we need to do? Just draw free body diagram for this. So say this is 1.8 kg or say mass m, and then in this direction, mg sine 37 will always act. In this direction, as it is connected through string, T will act, okay? And perpendicular to the incline, what will act? N will act, okay? So there is a pseudo force because it is accelerating. On the accelerating frame, this is there. All surfaces are smooth. So therefore, horizontal direction, I will take MEA, okay? So if this is 37 degrees, this is also 37. This is also 37. So along this direction and this direction I can resolve it. So but here I need to find out only T. So to calculate T, I need forces acting in this direction. So its component acting in this direction is MA cos 37. That's it. Okay, so I'll write the equation of motion for this. T equal to MA cos 37 plus mg sin 37. That's it. Mg sin 37. That's all clear. So just now we have derived acceleration expression and it is 5/6 meter per second square. Clear? So acceleration is calculated in the previous question, which is equal to 5/6 meters per second square. Actually, it's a paragraph question. So I'll substitute that value here to get T. So, right, M is 1.8, acceleration is 5/6, cos 37, how much? It's 4/5 plus M is again 1.8 into G, 10, sin 37, 3/5, okay? So I'll take out 5 cancel, 5 2's cancelled. So 1.8 you can take out common. Inside you have 2 2's, 2 3's. So I have 2/3 left in this term, and this side you have 6. 2 into 3, 6. So I can write it as 1.8 into 3 6 is 18, 18 plus 2 20, so 20/3, okay? So 3.6 is, and it becomes 6 2's 12, right? So this is the final answer for us. So I think this is the correct answer. Able to understand? So in this problem, what we need to do, we have to resolve forces, same like the previous case. But for us, in this particular case, forces acting down the plane and up the plane are important because tension is acting up. It is balanced by the forces acting in the downward direction, and because it is in equilibrium. So we have to equate force acting in this direction to force acting in opposite direction. Clear? So therefore, T should be equal to sum of these two forces. How many forces are acting actually here? Normal force, normal to the incline, and MA, right? Opposite to the motion of the wedge, that means horizontally leftwards, weight vertically down, okay? Weight vertically downward direction, T along the incline up the plane. So if you resolve this into components, what you will get? Along this direction, mg cos 37, and along this direction, MA sine 37. This is how you can resolve it, and according to the situation, you can use the equations. So along this equation is, this is equal to sum of these two forces. That's what I have taken. So A is calculated already, so I have substituted all these values and I got 12 newtons, correct answer. Along this direction, we are not interested here in this particular problem because we are asked to find out only tension in this case, right? So that's all. Let's see the next question. So this is the third bit of the same paragraph. So we know alpha is 37 and this is 1.8 kg and there will be tension in it. And in this case, what you have to find out, at what acceleration will the body lose contact with the plane? So it should lose contact with the incline. So what is the condition to lose contact with any surface actually? To lose contact with any surface, normal force should be 0, right? Am I correct? So to lose contact with any surface, normal reaction should be 0. So that means take the inclined plane surface and keep the body on it and represent all the forces acting on it perpendicular to the incline. So along this direction, normal is acting, clear? And we know along this mg is acting. Along this mg, cos 37 will act. Along this mg, sin 37 will be acting. So this angle is given 37 and in this direction t is acting and you have pseudo force acting like this. This is MA. So this is how much? 37 obviously, correct? This is 37. So if you resolve this into components, okay? If you resolve this into components, along this direction, you get MA sine 37. Hope you understood. So along this direction also, we have to resolve this, but that is not important for us now. So what you have to do is, we have to find out at what acceleration will the body lose contact. So therefore, consider this direction. In this direction, for its equilibrium, n plus MA sine of 37 should be equal to mg cos of 37. That's all. So to lose contact, n value should be 0. Okay. Actually, directly if you want to write, so acceleration should be g cot theta. Okay. Acceleration should be g cot theta. That's it. So n is 0 here. So if I cancel n, and m also gets cancelled obviously after cancelling. So we get acceleration equal to g cos 37 by sine 37. That means basically you are getting g cot 37, right? What is this? G cot 37. Okay. So what is the answer? G cot 37. That is the answer. G is 10. Right? And this will be 4 by 3. So the answer is 40 by 3 meters per second square. So that's so 40 by 3. Okay, I'll write it here like this. So this is 40 by 3 meters per second square. Hope you understood. So consider the equilibrium of this block in this direction. It has to lose contact with it. To lose contact with it, here normal force acting between them should be 0. Then this force should be equal to this. That's what I have done. So on equating, mm cancel and we get acceleration as 40 by 3 meter per second square. Hope it is clear. So let's see the next question. Okay. You have a uniform rope, okay? So it is basically a rope tied at this point and at this point, okay? And it is actually in equilibrium, and in equilibrium it is in curved shape like this because it is connected at the two ends and it has a weight. Because of that, it has a curved shape. So what we have to find out in this particular case is, here with respect to vertical, at the point A, it is making an angle alpha, and with respect to vertical, at the point B, with respect to, if you draw a tangent here, it is making an angle beta. Okay, so what actually you have to find out is the correct statements in it is how much. What are the correct statements in this particular case? So you see the option A, horizontal component of tension in the rope is uniform. Horizontal component of tension in the rope is uniform. So that means, for example, if I draw a tangent here and say this is the tension at this point, you can resolve it into components, right? Along this direction, what? T. Suppose if I assume some alpha, so I can assume it is t cos theta, this is t sin theta. Or at any other point, if I draw a tangent, okay, tension at this point and at this point, and if I assume with respect to vertical, it is making an angle theta, making an angle theta. So along this direction, okay, along this direction, you have t cos theta, along this direction t sin theta. Or if you consider, I'll draw a free body diagram for this. I'll take tangent like this, okay. So I'll take, because here horizontal component of tension in the rope is what, okay. So this is the vertical and this is the tension direction. With respect to vertical, if it is making an angle theta, what you can write? Along this direction t cos theta, along horizontal direction this one t sin theta. Anyway, along horizontal direction, directly we can write that there is no force. Along horizontal direction, which force will act? No force, no, on any body in this freely connected string. There is no force along horizontal direction. Able to understand? You resolve anywhere this component of force acting along this direction should be same. Okay, so a horizontal component of tension in the rope is uniform. Of course, this is correct. Along horizontal direction, whatever be the component, that remains constant. But why it will change along vertical direction? Because weight acts, no? Rope's weight will be acting. Suppose if you are moving from here to here, as you are moving upwards, then what will happen is weight will be increasing. As the weight is increasing, obviously vertical component of tension in the rope will increase. Okay. Along horizontal direction, component of force remains constant. Correct. Along horizontal direction, component of force remains constant. So therefore, component of tension, what force? Tension will be uniform. Because weight acts only vertical direction, there is no other force acting along horizontal direction. So therefore, obviously, along horizontal direction, no other force is acting on the rope. Therefore, whatever component you get, anywhere if you draw a tangent to this string, you draw, this string is like this, you draw anywhere you like, in any direction you like, but it's a horizontal component. On resolving it into components, its horizontal component should be constant because no force. But vertical component should gradually increase. Why? Its weight is increasing. As you are moving up like this, weight will be increasing. Because of the increase in weight, vertical component obviously increases. Okay, anyway, theory bit, nothing is there to prove here. Alpha can be greater than beta. Alpha can be greater than beta. Beta is, so alpha can be greater than beta. No, this is not correct. Alpha cannot be greater than beta because it is, at a higher level than this. So obviously with respect to vertical, so at this point angle will always be greater than this. If you make it, if the height is increasing, alpha value gradually be decreasing. And the last option is alpha is not equal to 0. So that's correct. This is correct because they are fixed like this. So always there will be some angle here. It cannot be, the rope cannot be along the wall. It cannot be along the wall. It cannot be fixed like this. So therefore alpha can be not equal to 0. Okay, it can be greater than 0. So that's it. So this is correct. These two also correct. So let's see, 3 equal weights A, B, C of masses 2 kg each are hanging. Okay, so that means here all the masses are 2 kg only. This is 2 kg, this is 2 kg, this is also 2 kg. Hanging on a string, passing over a fixed pulley. So the pulley is fixed, obviously it is fixed. The tension in the string connecting weights B and C is how much? So that means basically you need to find out tension here, okay? So what is the tension at that point? Okay, so to find out tension here, what you need to do? Find out actually acceleration of the system, right? So what is the acceleration of the system? Acceleration is nothing but net force by total mass, right? Mass total. Can I write like this? Right? This is a shortcut, right? So what is the net force? This is 2, and total mass on this side is 4g, 4 kgs. So total force in this direction is 4g, and this will be moving upwards. So 2g is moving upwards and 4g is moving downwards. Hope you understood. Acceleration is upwards for this, acceleration is downwards. So in this particular case, all 3 blocks will move with same acceleration, you know that. So now acceleration is, net force is 4g minus 2g. This is the net force. Okay, 4g is acting down, 2g is acting up. So this is the net force by total mass. What is the total mass? 2 plus 2 plus 2, 6. 6. So therefore it will be 2g by 6. So this is equal to g by 3 or 10 by 3 meter per second square. So I have calculated acceleration, isn't it? So after acceleration, you can easily calculate tension in it. So for that, consider free body diagram for this. Okay, so I'm taking block C here, and what forces are acting on it? So its mass is 2g is acting down, and it is accelerating down. Clear? We assumed it moving downwards, and there is a tension here, okay? Between B and C, there is a tension. I assumed it as T. Okay, so what is the force equation for it? It will be 2g minus T equal to 2 times EA. That's it. Already acceleration is calculated. How much? It is 10 by 3. Right? 10 by 3. So right side we have 20 by 3. And left side you have 20 minus T. So make T as subject. So T equal to, send 20 by 3 left side. So 20 minus 20 by 3. It will be 60 minus 20, which is 40 by 3 newtons. So this is the answer for this question. Hope you understood. So we don't need to find out tension in this string. Only we have to find tension in this part. Okay. So between B and C, what is the tension? For that, what I have done is I have calculated net acceleration. So how to calculate net acceleration? Net force by total mass gives acceleration. What is the net force here? You know, if you assume this is 2 total 4 kg. 4 kg is more than 2 kg. Therefore, we can assume that this system is moving downwards. So 4g is acting down and 2g is acting up. So therefore, the net force becomes 4g minus 2g, which is equal to 2g. Total mass is how much? All 3 blocks we have to consider. Their mass is 6 kg. So 2g by 6 becomes g by 3, which is equal to 10 by 3 meter per second square. So after that, what you have to do after calculating acceleration, you need to draw free body diagram for this 2 kg block. So in the free body diagram, body is moving in the downward direction. So this is a greater force than it. So or otherwise net force is downward direction. So therefore 2g minus T equal to mass times acceleration. What is its mass? 2 kg. So 2 times acceleration. Acceleration is how much? 10 by 3. On simplifying, you get 20 by 3. So 20 minus T equal to 20 by 3. If you make T as subject, you will get this. So hope you understood. So this is the answer for this question. Let's see the next one. Okay. Okay. So you have one more question here of pulley block systems. In this, what you need to find out is basically it is a constraint. Am I correct? Relation between their accelerations. Acceleration of B is given as x times acceleration of A. That means you don't need to worry about directions, moving downwards, moving upwards, we can ignore. Okay, only magnitude relation. Acceleration of B equal to x times acceleration of A, correct? So that's what you need to calculate. So in this case, what we'll do? Mass is not mentioned, correct? Only direct constraint equation we need to find, okay? For that, we'll assume tension here as T. And this is the same string, so in the same string tension will be same. If it is T, this will be T, so then how much it would be? 2T. So in this, tension is 2T. Okay. So I'll assume this is moving downwards. So acceleration of A is moving It is moving downwards. If it moves downwards, I can assume this is moving upwards. Acceleration of B upwards. Okay. B is moving upwards. That much we can assume. Clear? A is moving down, B is moving up, right? So now let us use that, work done by tension method or virtual work method. If I use that, if I consider block B, tension on it is upwards and block A is also moving upwards. And if I consider block A and it is moving downward direction with an acceleration A, but tension on it is how much? This is T, this is 2T. Totally how much? 3T. So 3T is acting up, body is moving down. So let's use the net work done by this system. So this is minus 3T into acceleration of A, correct? And in this case, this will be T into acceleration of B should be equal to 0. Hope you understood. What I have done is sigma T dot EA should be 0. Okay, net work done by tension in a pulley block system is always 0 because net tension in this system is 0. Our net force is 0, so work done is 0. So therefore, I have written, I have used that point. Okay, hope you understood. Because it can be written as T bar dot V bar is 0 net power. Otherwise, T bar dot X bar. This is the actual work done. It should be 0. If it is 0, obviously this will be 0. This will also be 0. So I'm using this concept. So therefore, you can get this equation and TT cancel out. So we'll get 3 times acceleration of A equal to acceleration of B. So I got the answer now. So 3 times acceleration of A equal to acceleration of B. So what is acceleration of B? 3 times acceleration of A. So if I compare it with the given data, X should be 3. Hope you understood. This is very simple shortcut. If you use this virtual work method in case of pulley block systems, we directly get in one step the constraint relation. Okay? Is that clear? So next case, next problem, let's see. Okay, so in this, the force is CT, that means the force acting here is a variable force. Force is given as CT. Okay, if CT is applied on a small body of mass m. So what is the mass of this body? M. At an angle theta, of course it is represented here with horizontal. So what we have to do? The velocity of the body at the moment it is breaking off. So what is the velocity? So that means velocity of the body at the moment it is breaking off. Okay, basically why it breaks off? Breaks off. That to understand that you need to see the direction of force. So force direction is like this. It's making an angle theta. Okay, so along this direction, F cos theta, cos component will act. Along this direction, F sin theta will act. Okay, and this force is a variable force, isn't it? Force is a variable force. See here, force is variable force CT. So force F is CT. So I'll take a small t here. So that means it's a function of time. Time always increases, isn't it? So as time is increasing, F will be increasing. As F is increasing, this component will increase, right? F sin theta component also increases, no? Because of F cos theta, it will have horizontal motion. But because of F sin theta, what will happen? Because of F sin theta, what will happen? It loses contact. Because as time increases, F sin theta component also increases. Because of that, what will happen? It loses contact with it. So at the moment, it loses contact. At the moment, it breaks off. What is the velocity? That's what we need to calculate. That's it. Okay. So anyway, velocity, its velocity is due to this force only, no? This force only, no? So therefore, I will write, so F cos theta, I will write as the net force that causes its motion along horizontal direction. Actually, it is moving like this. That motion is due to this component only, no? So therefore, I am writing this is the net force, which is equal to mass times acceleration. But F is what? CT. So CT cos theta equal to m into acceleration can be written as dv by dt. Okay, acceleration can be written as dv by dt. So dv can be written as c cos theta into t dt, clear? So I have simply sent dt and m this side. So that means it will be like this. Just make dv as subject from this. You can write acceleration as dv by dt now. So ct cos theta equal to m times dv by dt. So this is dv expression. Now what we'll do is we'll integrate. All these are constants, so out of integration. So what is initial velocity? 0, because when time t is 0, f will be 0. When f is 0, it is at rest. So lower limit should be 0. Upper limit is say v. And here, this is 0, this can be t. So therefore, if I simplify it, what I will get is, on left side I will get v. That is equal to c cos theta by m into integral of t dt is t square by 2. T square by 2, that's all. So this is the expression for velocity as a function of time. Correct? When it breaks off, in one problem we discussed that any body breaks off from any surface when normal reaction becomes 0. Clear? When normal reaction becomes 0, then only it breaks off. Correct? So if you consider this, in this direction weight acts. Correct? In this direction normal force acts. It's free body diagram, clear? So if I consider vertical direction, what I will get is f sine theta plus n equal to mg. But when it breaks off, n should be 0, clear? What is f? ct. So ct sine theta is mg. So when it breaks off, n is 0. When n is 0, what is the time? So time t equal to mg by c sine theta. Hope you understood this point. This is the time at which it breaks off. This is the velocity at any time t. Suppose if this t equal to this, then you get velocity at the time it breaks off. Able to understand? So if I substitute this t in this expression, what will I get? I will get the velocity at which it breaks off. Hope you understood. This is what? It is the time at which it breaks off. How can you say it is the time at which it will break off? Because here I have taken, this is the condition for its equilibrium. mg is acting down, n is acting up, f sine theta is also acting up. But when n becomes 0, when this becomes 0, it cannot remain on the surface. That means it will break off. So under that condition, I calculated t here. So t is mg by c sine theta. It is the time at which it will break off. Then what I will do is, if I substitute this value in this, then I will get the velocity required. That means that is the velocity with which it leaves or breaks off. So I will substitute here. So I will get v equal to c cos theta by 2m. What I am doing? I am substituting in this formula. C cos theta by 2m into t square. T square means what? M square g square by c square sine square theta. Bas, that's all. So this c and this cancel out. M and m cancel out. So what is left out? M into g square into cos theta by 2 times c into sine square theta. So this is your v. I think it is clear. So now let's see for this option. See, m g square cos theta by 2c sine square theta. Okay, of course here also there, right? Okay, mg square cos theta by 2c sine square theta. So you have this value in 2 options. In these 2 options. Clear? Right? In these 2 options, you have correct value of velocity at which it leaves the surface. Now, what else we need to find out? The distance traveled by it before it leaves. That's it now. Before it breaks off, how much distance it travels. That's what we need to calculate. Yes or no? So to calculate the distance traveled by it, again I can use velocity expression. Right? Whenever you have velocity and if you want to find out displacement, what you will need to do? So velocity can be written as dx by dt and make dx as subject and integrate it, you will get it. So that means from velocity, if you want to find out displacement, you need integration method. From displacement, if you want to find out velocity, you need differentiation, correct? So here I have velocity as a function of t. I'll take this equation and write v as dx by dt, where dx is the displacement. So let's take this expression, because I cannot take this. It's a fixed value at which it is living, but this is a function of time. So this is a suitable expression of velocity for finding out displacement in t time. So I'll use that equation and write velocity as dx by dt, rate of change of displacement equal to c cos theta into t square by 2m, correct? I'm using this one. And now what I'll do is I'll make dx as subject. Let's make dx as subject. So I'll get c cos theta into t square dt by 2m, right? Now I'll integrate both sides, okay? So I'll integrate both sides. So initial displacement is 0, finally say x. We need to find out that x. And initial time, we can say 0. The time at which it leaves is say t. Then left side you get integral of dx is x now. So x equal to c common cos theta common y constants. I'm taking out 2 common m also taken out of integration. All these are constants. What is integral of t square dt? Integral of x square dx is x cube by 3. Similarly, integral of t square dt should be t cube by 3. Okay, so therefore I got displacement as a function of time. So how much is this? C cos theta by 2 3s are 6m into t cube. What is your t? This is the t. Why it is that required t? Because it is the time at which breaking off is taking place from that surface for that block. So I'll substitute that value here. So that will be, if I do directly, m cube, and then I can write g cube by c cube sine of cube theta. Why should I take here? I have 2 cube. I have cube here, so its cube I am writing here. So I have written here. So you can assume that c and c cancel out. So finally what is left out I'll write, okay? So because you have m here, m cube here, so m square is left out, okay? And g cube, so it remains m square g cube, and here c cancel. I have only cos theta in the numerator by this m cancelled already, so there will be 6 here, and what is left out here is c square is left out and sine cube theta, sine cube theta. So this is my displacement expression. Okay, so this is the displacement of the block when it leaves the contact. Before it leaves the contact with the surface, this would be the displacement. So let's check where, in which option it is present. M square g cube cos theta. So here you have m square g cube cos theta by 6c square sine cube theta is there in this option. Here it is not there. So this is wrong, but this is correct. So this both are correct in this case. So therefore, second option is the correct one. Able to understand? Okay, hope it is clear. Okay, so what I have done, see, let's see once. You have force here, its component f cos theta, other component f sin theta, because it is making an angle theta with respect to horizontal. So this is the component of force responsible for its motion. This component is not responsible for its horizontal motion, but it is responsible for it to break off from this surface, correct? So this is the net force for the horizontal motion. So net force equal to mass times acceleration along horizontal plane. So in place of F I have substituted Ct, and in place of A I have substituted dV by dt, and bring dV this side and the remaining terms the other side, and on integrating you get on left hand side V and right hand side you will get this kind of expression. Clear? Okay, so we have this velocity as a function of t, and here what is t? T, if you want to find out velocity at which it breaks off, then you need to find t at which it breaks off. Okay, after what time it is breaking off, that we need. So when it will break off, for that you need to see vertical equilibrium. Along vertical direction f sin theta and n are acting, along downward direction mg is acting. When n is 0, if n is 0, it will leave. That means f sin theta should be equal to mg. F means what? Ct. Ct sin theta is mg, means what is t? T becomes mg by c sin theta. That's it. This is the time at which it breaks off. So I am substituting this value in this formula to get breaking off velocity. This is the velocity with which it leaves. And after getting this, in place of v, I'll substitute dx by dt, because rate of change of displacement is velocity. I'll substitute that value and take this velocity, which is function of time, and then make dx as subject, and then x. On integrating we get directly x. Hope you understood. Integration is completed. In place of t, you have to substitute this value, and on substituting it, we get this kind of answer. So hope you understood. Second option is the correct one. Okay, so let's see the next one. Okay, guys. So that's all for now. Hope you understood this session. So that's all. Take care. Bye bye.